So I'll start. I think we have a good quorum here. Again, thank you for coming. My name is Samitra. If I speak a little fast, please slow me down. Um, I run the HDP product management in Hortonworks. So that really includes, let's see if I can. Which button I press? The green button? Okay. All right, so I run HDP product management. So Hadoop core, I am responsible for HDFS, yarn, container work. Also, we're working on a thing called Ozone, which is our next generation file system. It's going to come around June, July timeframe from a tech review standpoint. I also run data science. Recently inherited data science at Spark, Zeppelin, also partnership with IBM DSX, and data lifecycle management. That's the product we're going to talk about today. That's me. Sorry. Why is not working? Green button. Okay, sorry. So, a quick icebreaker. I came from San Francisco. My incoming flight got delayed, so they connected me from Newark. Instead of coming Newark to Berlin, they connected me to Newark, Heathrow, and Berlin. And they didn't have a seat for me. They have a flight for me, didn't have a seat for me. Somehow I made it, but my bag didn't make it. So I was on one pair of clothes yesterday, but finally my bag came last night. So I have to at least have a formal clothes now. That's a joke. So quickly, I don't know how many guys have heard a product called Data Plane Service, DPS. It is what DPS is a centralized way to secure, manage the lifecycle and govern, whether it's in the cloud, on-prem, between, in motion or at rest. So traditionally, our product has been mostly HDP, right? At rest, HDFS. We introduced a product called HDF in flight. What Data Plane does is, think about an app store on top of everything. It brings apps to us, right? And one of the first apps are going to be in our dogfooding is DLM. That's what product we're going to talk about today. We also launched DataWorks Studio, especially for GDPR, and we announced it today. So DPS, in a way, when I do demo, you'll find out that DPS is a platform baseline that connects to all different data sources. HDP clusters, it can connect to any HDP clusters as long as 263 and above. And it also does centralized RBAC, so it connects to all the global LDAP. And then you can say, okay, person Tom, he's user admin. Person Ben, he's user infra admin. I can give the RBAC control. And based on the RBAC control, the person can use the apps in there. And then, of course, there's security policy assigned specifically to the HDP clusters. For example, if I'm a backup or DR admin, I want the person to see the directory structure, but not only to see the data, because he has to go and replicate the structure. But I don't want the person to be able to see the data. So those are things we're doing in-house to make it better. So quickly, again, DLM, as the name says, right? It's a Data Lifecycle Manager, or DLM. It's not just the one product, it's a multiple product as part of that. First one is called Replication, failback. If you have a separate site, for compliance reasons, or for, production and all the cluster, you move data, we need replication to the cloud on-prem. So that's our first focus. Second focus is going to be tiering. As you have multiples of data, petabytes of data, you cannot just have always 3 copies. You want to make sure it goes to a cold data or in the cloud. So tiering helps you, instead of having 2 copies of data on replication, tiering helps you move part of data, move it to the cold site. So that's tiering in a very simplified manner. And you can create policies to go back and come back. And we'll do all those based on access pattern. Backup restore is, again, different concept. What it means is, if I am accidentally going to delete a database, if I replicate what happens? The logical error moves along with replication. I delete it, it gets deleted on the other side. What backup does, it keeps me 30 days of copies. Day 1, day 2, day 30, right? So if I delete, I can go back to yesterday's snapshot. So our intent is to support backup restore of HBase, HDFS, Hive, all in one single pane. So this is the product going to do all these things from a single pane. It's the first service I was talking about in DPS. It requires HTTP 263 and above, and it's all completely built in open source. So HTTP on Apache, version 2. DPS is going to be 1.1 is going to be based on AGPL. Again, this is the first view when you create a product. This is what you started with, like complete blank slate, like a napkin, right? How the product is going to look like before you build a product. So we said, okay, what are customer problems? I have cluster 1, cluster 2, right? Separate sites. I have data set. You cannot just have one cluster sitting completely idle doing nothing. It's always active, active, hot, hot, right? So data set here, A in that, data set B sitting here. So now what we're doing is we can allow you to do data set level replication. So you can do Hive HDFS replication and with schedule policy. And when I do it, we not just copy data, we also copy schema and metadata for Hive. You don't have to worry about all these things. We'll automatically take care of that. We're also going to copy security policy. We also copy, not in this release, next release, we're going to copy governance, lineage, all the information, whether you go to cloud, on-prem. And now, let's say in this case, disaster recovery happens, the site goes down. We can make this guy active. We do want to have this read-only behavior with ranger policy because we copy the policy. We copy policy first, then data. The secure, and then on top of that, we can make it deny policy, it's read-only. But now, so we want to make it read-only so that there's a single source of truth behavior. But if the site goes down, I want to make this guy from read-only to active. So that's called failover. So B becomes active, this guy goes down. Now I keep doing some work on it, right? It changes, B prime. Now this guy comes back up. So what I do, I fail back. So when I do fail back, it's not just copying the entire data set back. We're talking about petabytes of data. So we have to only bring the delta between B and B prime. That's called failback. So this is a very simple flow, but we're going to do it. And in next phases, right beyond this, we might also look at workload level replication. Once you containerize your workloads on the cloud here, we can also move the workloads. So very seamless, entire HTTP-wide DR. And you can also include HBase, Kafka, all these things are going to be part of the solution. So high level, how the deployment works is you have cloud, on-prem, clusters 1, 2, 3, 4, and then you have operating clusters, so distributed cluster 5. And what happens is, before you can replicate, you have to install an agent called DLM engine. So the engines get installed in all the operating clusters, and so distributed cloud storage. And you have to install 263, or next version of 265. That comes with DPS 1.1. We launched the product, announced it today. So once you install it, then we have the UI, which is going to be sitting outside these two clusters. It's in a Red Hat 7.2 box. It's using containers. So as long as you have a box with certain memory and CPUs, we can start replicating for you. And I'll kind of give you a demo today how it's going to work. Actually, it's pretty cool. High level, how it's designed. It's designed from ground up. I mean, in a way, in 3.0, HTTP 3.0, right, some people are asking, Falcon is going to be removed. We don't have Falcon anymore. We deprecated the Falcon some while ago. Think about this is not just a Falcon UI replacement, this is a ground up design from the ground up. So we redesigned a product. We said, what are lacking today? We don't have high replication, incremental replication. We fixed Hive to make it happen. So in 263, we spent a lot of money, resources, half of our team on Hive working on incremental replication. So we went here. We also changed Ranger to do import-export of policies. So if I replicate a metadata, Ranger policy automatically gets replicated. You don't have to go to Ranger UI and do all these things, right? So that's that HDFS. We have snapshot. I fixed snapshot limitations to make it work. And then we fix a whole bunch of things here. One is the scheduler. It doesn't use Uzi as a backend engine. It uses different schedulers to make everything working seamlessly. And of course, it has its own MySQL database or Postgres to store the states, and that's the UI. And think about these are the components inside the cluster, right? The green bucket. So for 1.0, it's 263. For 1.1, it's 265. A little more detail. So we call it Beacon. That's the internal name, but it's really DLM engine. So it needs to be installed in every cluster that you want to replicate. Also, you need to make sure both clusters are symmetrical. If I have Ranger on both sides. If you have HA, you have HA. Carbros, non-Carbros, non-Carbros. It has to be symmetrical. And DLM engine is installed as an AMP pack, right? And then we can interface with the data plane UI. Then we can schedule, manage the policy, and we support all the subsystems. One key part about Hive replication is that we support incremental, right? That's a key part. So anytime you do any table creation, insert, update table, right? It becomes an event. That event is replayed on the DR site or at the address destination site. When we replay it, it takes care of metadata and data. And also, we're going to copy Ranger policy along with the data. So take care of HDFS, Hive, and Ranger. In future versions, we'll have HBase, Atlas, Kafka, all these are coming as part of this. And that's only for application. Then we have backup and tiering products, right? From a feature perspective, again, just to summarize everything, this is a screenshot. I'll give you a quick demo, how the product looks like. Hive, HDFS, Ranger. We also support active standby. So you can see here, right, this is source and destination. We have a thing called read-only. Anytime you have Ranger enabled, by default, we'll copy the Ranger policy before copying the data, and then we apply deny policy on the destination. So what happens is, the data, you cannot go and edit the data now. It's a read-only. You can query it, but that means that you have a really clean copy of data, and this is your source master copy. If this guy changes, this data on the DR side will change as well. So it's a very clean way of doing it. If you want to override that, there's a way to do that, but I don't recommend that. That's DLM 1.1 features, Q2. We announced it today. So cloud storage replication. So we are supporting HDFS replication going to cloud storage. So I can move data incrementally to S3. And after that, we'll look into ADLS, WASB, and eventually Google Cloud Storage. GCS will come a little later, but ADLS, WASB is next phase, and then GCS. If I have to get a show of hand today, how many of you are using AWS? Okay. And how many are you using Azure? Okay. How about Google? Okay. So with the right priority. Okay, good. So actually, that's what we're seeing on our customers too today. So once you replicate, again, this is incremental. So if it's snapshot based, you don't have to have a HDFS file system. We incrementally copy data. Encryption, that's again important one, especially with today's environment in Europe. This is one of the key features we're lacking in OneNote. So we're going to support TDE, address encryption. So if you have data encrypted with one KMS or multiple KMS or one key or multiple key, we will help you replicate that and address data to the DR side or application side. If you have a clean, clear text, not TDE, but you want to send the data over a WAN link, and you want to encrypt the WAN data, then you use the data in motion, TLS. We can also do that. There might be a small penalty overhead, CPU overhead. We all know that. That's nothing different. So it's not a whole lot, but do run through it and do a POC, but that's also supported in 1.1. It's going to come out in May from a GA. We are very close, running betas and stuff. It's going to come in May. I'm going to skip the slides here. It's more detail. This is a user flow. So I'm going to kind of walk you through a nice demo, what they're doing, and then open up for Q&A, right? So that's probably that you'll see the real product, how it's being done in real life. So this is a DLM view. I'll give you more demo than this. Here you have the cloud credentials, so you can replicate to cloud storage. So add it, and then you can put everything access key. We can also support ADLS WASB in the next release. So with that, let me show you the UI, and then you can ask me questions. So think about this is the data plane. Right, when I showed you HDP, HDF, data plane, Uber, this is our interface. You log in. Depending on how you log in, what you log in as, it's going to give you the right credentials or RBAC control. So in this case, I'm going to log in as an admin. This is running in US, so there's lag, but so this is the interface that you can see. This is a working product. We have a GA in October, but this is the next iteration of the product. So you can see the clusters, 3 clusters. One in the West Coast in US, California. The cloud one is in Budapest, and then one running in India. Right, so 3 clusters, 2 on-prem, 1 cloud. So you can also now add clusters, one more. All you need to do is take the cluster, put the Ambari URL, put the username, password, you're good to go. And then what do? You add users. So you don't want everyone to be admin and mucking around the user permissions or adding data or users. So you can decide who gets to do what. So if you look at the rules here, there are 3 personas. So first one is data plane admin. That person can do anything. He's the admin. He can come to the screen, see it, add users, add a service in the App Store. Second one is infra admin. This is the person who needs to know about yarn queues, details of the network bandwidth, right? Very details, low-level operator. So that's called infrastructure admin. So that person is responsible for DLM, the product we're talking about. And then there's a data steward studio persona. Data steward persona, that person is responsible for security and governance. And that they're going to use data steward studio. We launched the product, announced the product today in the keynote. Actually, there'll be more. You should come tomorrow. In the keynote, we're going to have a demo of the product. So that's users. And this is where you add the services. So in this case, DLM is already enabled. As long as you have a Smart Sense and HTTP 263, and in newer versions 265, we're good to go. It's already enabled for you. So let's say this is the setup. I'm a data plane admin. I set it up for you. Now I come in as a DLM admin, right? So I log out. I log in as DLM admin. In this case, I should only see this view, DLM view. So that's the next view. So this is a DLM view. So this is a dashboard. You can see, 3 healthy clusters, 1 policy. I can suspend the policy. If I create, I can stop it. I can run it again. So I can do all those things. How many jobs running? No jobs running because there's no data changing. Only the data changes, I run a job. If it doesn't change, there's no need to do anything. That's why incremental comes in. And then I think once you have that, what you next do is The cloud clusters you added is already in there. So 3 clusters. This is where you get the credentials of the cloud storage. So S3 for now, but you can do ADLS and WASB later. Pairing is an important concept. What it does is it does handshaking between clusters. So I can replicate, I have the intent to replicate between the clusters. It takes only a few seconds, but it also makes sure that both clusters are symmetric. So once the pairing is done, then you can add a policy. Then it takes you to a wizard, and then it'll help you create the policy. So in this case, I'm just saying, let's say Berlin. Then I can select the source. In this case, if I give S3, I have a bucket. But in this case, I'm going to pick, say, from on-prem to cloud. I choose the cloud. I can choose any, let's say I choose this log here, right? That shows up here. Then I select destination. Let's say I go to S3 now. I select the bucket already added. And then I can add a schedule. I'm not going to do it right now, but that's the view. So this is kind of the end-to-end flow, right? I'm going to show you how it's working in function right now. So this data set, it had a data set table called traffic data. So we have it already installed. Let me see the policy is running. I can suspend the policy. Let's say I don't suspend it. I can suspend it. I can reactivate it. It's basically going to run every minute. And if there's a delta, it's going to replicate. Our first version are going to support 1 hour RPO. But we'll probably do much better than that. But start at 1 hour RPO. Our eventual goal is to get to minute level RPO. So this is where it gets interesting now. So I'm going to show you 2 Joplin dashboard. So it has Hive interpreter running in here. So this is the source cluster with traffic data, right? In the background, DLM is running replication. There's no change, it's not running anything, right? Only there's a change there, it's run something. So you can see here, this is the traffic data, right? It's talking to the clusters. There are 3 partitions, right? So this is already replicated here to the destination. Let's say I just checked how many, there are 3 partitions. They're all in sync, right? DLM is supposed to keep them in sync. Now, I'm going to add a partition, 4th partition, and see how in real time it gets moved to the other side. It's going to take 4 seconds. OK, it's done. Let me add the partition. OK. Let's make sure it's in there. It becomes 4 partition. OK, so you see here, right? I added a new partition called Queens. So that's in this table, right? So I added here. Now, let me go and check what's happening on the other side, on DLM side. With DLM, I can look at a job instance. See here? There's nothing running, but as soon as the change kicked in, it detected that, and it just ran that. Before that, there's nothing changes. It just doesn't do anything. That you can see here, it moved 2 tables. So now let me go back other side and see if it got the latest. See here, that's the 4 partition. So really incremental, really quick, and we make it very, very easy for you to use. So that's the kind of beauty of the product. Again, this is a starting point. Our goal is to do it across the SDP clusters, HBase, Kafka, and we own all the endpoints. We'll make the changes just like we did for Hive, and those will go back to the community, right? So it's a pretty powerful product from our side. So once we do the replication DR, failover, failback, and that's also require a lot of investment from our side, we'll be looking at tiering for HDFS, and then backup restore of HBase, HDFS, and Hive. And of course, that's the next level of thinking, but we can do more than that, but that's current line of sight. So just to make it more interesting, right, let's now delete the partition, right? Drop the partition. So it executed. Let me see here. I don't have it because it hasn't done the replication yet. Let me go and see where the replication job is. So it's going to kick in because it's every minute. So as soon as it kicks in, then you can see the other guy is going to reflect the drop partition. So from 4, it's going to go back to 3 on the destination side. See here, it's kicked in. There you go. So those are the things we're doing under the hood, right? A lot of work going into making it happening. We also are going to support encryption with the cloud, ADLS, WASB, Google. No one cares here, but at some point we'll do it. But that's what we're doing right now. So we have customers who are bought this product. We just launched it like in October. After October, we hit the end of October. Then we hit the Thanksgiving. So that's pretty much a very cold period. So really started in January. So we already have 3 customers now. And lot of interest, really strong interest in the market. And we have a lot of focus on it. I personally, my background is I did a startup before that, my startup in the Valley. Before that, another startup got acquired, the WD. I was an EMC, ran their strategy for virtualization. So this is, we really want to make this work for you guys. So hopefully, you get some feedback from me. If you have questions, feel free to reach out to me. What else can I tell you today? Let's see. We did a demo today. This is a customer use case, 3 customers that we're talking about, right? So it's all across pharmaceuticals, financials. One is in Europe, who recently closed. Also employee service directory industry. So all kinds, petabyte scale, 100 terabyte scale. They like security replication policy. They want it for GDPR compliance. I can also select a subset of data to replicate. That's really powerful. Tiering, they want tiering. Again, tiering GDPR is coming more often. And they also want to keep things in sync. So these are varied use cases. Hope it's useful for you guys. I can open up for Q&A. I still have about 7 minutes. So anything you have, yeah. Sorry, it's third row. Go ahead.
Do you have any eventual consistency issues when replicating to S3?
So we have a thing called S3 guard, Hortonworks. So what we do is we provide a strong consistency on top of S3. So when you're doing high replication, we work with S3 guard. So we test all to it back to end-to-end path. So we'll make sure that it's working. So we're taking care of that for you. Sorry. We do incremental of the partition. So today we're going to do the DB level application, but within the DB, if within the partition, any table changing, anything changing in the Hive, that's tracked as an event. So regardless of what it is, and we're going to replay the other side. So that takes care of all the deltas for us. No, we don't have to replicate a whole partition. So that all the changes went in. And at some point, we are doing a DB level application because all the views and all the stuff that is part of the database gets moved as an atomic unit. But once Hive supports ACID by default, we'll support table level application as well. question.
So if you create a table and you prime it cluster, does it create tables then from
Absolutely.
okay.
So
So you're not replicating Postgres to Postgres.
no, 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 no. That's a very bad design.
Exactly.
Yeah, yeah, yeah. If someone vendor is doing it, it's a bad design. We want to make it easy for you. We don't want you to say use this HDF. Otherwise, it'll be HDFS replication and schema you replicate, and there's no consistency, no synchronization between data and schema. We don't want that. We made it very easy for you. So Hive, we changed Hive to make it happen. So let's say event that has data as metadata, we replay the events on our side. Insert table, delete table, delete table. Do all these things synchronously for you. So if you do like every minute, I once heard doing 1 minute. This is for demo. I can do it. Small data. Do like a half an hour, an hour. Again, go through your own frequency on a pipe. We cannot break laws of physics. If it supports that, use the frequency. Again, this is a starting point. We'll definitely make it close to active-active. Table level is coming next phase. Now it's database level. Yeah. Sorry. Go ahead.
So is the system able to detect a replicate, say, insert a single row with a single that?
So I think I should repeat the question. I was told to repeat the question. Maybe I'll repeat the question, right? So the question is, if I do an insert on the source side, does it detect it and move to the other side? Answer is yes. Everything we do, it becomes an event. And we replay the event log on the other side.
Okay, so when I've looked at the metastore before, doing an insert doesn't actually hit the metastore. So what kind of event?
So that any operation that happens to Hive Metastore, we will know about it.
Yeah.
If you are coming outside Hive Metastore, I can't help much because then I lose the schema. I mean, that's unfair for us to do anything there.
So has the insert operation in Hive been updated then to also?
Exactly. So if it comes to Hive Metastore, we'll know about it. We'll move it along with data. We're not using HDFS snapshot for this, for Hive. It's really incremental forever design. HDFS, so think about transactional Hive. HDFS is more batch. I can go with a snapshot-based mechanism. Here it's event-based. And when I do HBase later on, I'm not going to use HDFS. I'm going to use something that works for HBase. So designed for the product. But again, all are going to be part of a single interface. You select the component you want. We're going to take care of it for you. Same thing for Kafka. Yes, go ahead. Oh, I see. So server request. The question is, what is the server requirement, CPU memory requirement on the DLM server? We have the requirement in our documents. So if you go, we should have that for you. It requires a little bit of CPU and a little memory because it's going to run, and it requires Red Hat 7.2 because ultimately it's running as a Docker container, kind of bunch of microservices. Think about our goal is to build this in the App Store, right? So first tab, one container, under container. So, but it's not that big of a deal. I mean, we can give it that. So question is it the replication for only text or is it for Hive structured data? So if I do Hive structured data, it's only for that. But if we do text, you go to HDFS and just choose the text file. Yeah, if the text file is related to Hive Metastore, is part of the Hive Metas table, then we'll do it. But if you have a structure on top and then outside, then you just do HDFS replication. Yeah, for unstructured data. Go ahead. It's optional. You can turn it on and off. So question is again, for HDFS replication or Hive replication, is encryption on and off optionally? Answer is yes. Optionally, if you want, you can turn on TDE or at rest. You can use along with in-flight or and or. And you can have multiple key or single key or one KMS, multiple KMS. That really depends on you. I would say 10 gig is required. I mean, for big data workloads, if you go like 10 megabit per second link, it's probably not a good design. If you really want a DR solution, 10 gig minimum. And then you have to really look at a source data, change rate, how often it changes. And then you have to do and see, what's the RPO requirement and design a link accordingly. One more thing is, the question is again, what's the 10 link requirement? So 10 gig and above. One thing is the first time we don't have a copy on the DR side. So there's no concept of replication or incremental. We have to move something first time. It's a lot of physics. So it's not us be delaying it. It's if you have the network bandwidth, it's faster, we'll move it faster. If it's slow, we can only go to a link that fast. So that's called bootstrapping first time. It has to be Hive managed on both sides. If Hive has a notion of it, we'll do it. If not, because I think it's a good design for you to go through Hive, so the Hive keeps track of schema and all. So yeah. I think there's one more question. Sorry, yeah.
Do you have the option to swap them?
Yeah, absolutely. Yeah, absolutely. I probably didn't cover it a little bit. Let's show me. Yeah, absolutely. You can add a policy. So there's the advanced option. Again, it becomes a wizard. I cannot get there right now. So again, sorry, the question is there advanced settings where I can do traffic shipping of the bandwidth or anything like that? In the advanced config, I have two things. One is the yarn queue, where it's going to run. You can choose the queue, and if you really want a faster processing, give a separate queue, run the jobs in there. Now, if you think I have 4 or 5 different jobs, this job is my CEO's file, you can give like let's say 10 Mbps bandwidth. And this is small, you can make it 1 Mbps. You can do traffic shaping. Tomorrow, you can also control number of mappers in that. So these are all the things we're going to add here in the advanced settings. All right, I think that's all I have. Again, any more questions? Last question here. Was it useful? It was okay. Thank you so much for your time. Really appreciate. So yeah.